Okay, so looking at heat and thermo problem 5 from the Get It series. Let's have a read of it and see how we go. I hate it already because it's got numbers in it, but anyway. A cylindrical copper rod of length 1.2 meters and cross-sectional area 10 square centimeters is insulated to prevent heat loss through its surface. Okay, the ends are maintained at a temperature difference of 100 degrees Celsius by having one end in a water-ice mixture and the other end in a mixture of boiling water and steam. Okay, given the thermal conductivity of copper is blah blah, the ice at the cold end of the rod melts at a rate closest to. Alright, so we basically got to find the heat flow through the copper rod, and it's a conductivity problem. Alright, now I reckon I'll look up a formula. I'll be lazy and look up a formula. That one looks good. So that is giving me the heat per unit time. So heat per second is given by K, which is 401. Times the area. Now the area is 10 square centimeters. So 1 centimeter is equal to 0.01 meters. So therefore a centimeter squared is equal to 0.01 squared meters squared, which is equal to 10 to the minus 4 square meters. So times 10 to the minus 4 square meters times, now we got, going back to the formula, we got the temperature difference divided by the length. So the temperature difference is 100, and because it's 100 take 0, or if you like 373 take 273, doesn't matter, it's 100, and the length is 1.2. So this is the heat per second is equal to that. So let's do a calculation. 401 times 1 exponent minus 4 times 100 divide 1.2 equals, okay, I get 3.34 joules per second. Alright, now, so the question is 3.34 joules per second. It's got to melt ice. How much ice do we need to melt? Well, a kilogram of ice, going here, kilogram of ice takes 334,000 joules. Okay, so that number's promising. So 334,000 joules will melt me a kilogram. So 3.34 is, whoa, much smaller. Okay, so it's basically a factor of 10 to the 5th. So I get my kilogram, which is 1,000 grams, and I divide by 10 to the 5th, and I get 10 to the minus 2, which is 0.01 grams per second. And I'm not happy because that's not the answer I've got. Right, why is the answer, why am I not happy? Okay, let's do the hand waving bit. So that's 3.34 by 10 to the 5th joules per kilogram, and double check this calculation again. 401 times 1 exponent minus 4 times 100 divide 1.2 equals, yep, 3.34 joules a second, and we need 334,000 joules. I've got 1,000 grams in kilos. I get 0.01 grams per second. I've got it wrong. Why have I got it wrong? And the worst thing is, having got it wrong, it matches perfectly well one of the answers. So I'd go A. Oh, I don't know why. I know why. Its area is 10 centimeters squared. So I put the 10 in there, and then I get 33.4, and then I get 10 to the minus 1, and then I get just 0.1 gram, and then I go there and I'm happy. Oh dear, just shows you have to read the question carefully. See why I hate questions with numbers in them? They're really annoying. Okay, so the answer is B. The ice melts at the rate of 0.1 gram per second. Now, how did the people go? Well, A was 12%, B was 55%, C was 13%, D was 15%, and E was 5%. Okay, so that was the most popular there. That's a good answer. And I would have got it wrong in this test, and I would have been kicking myself. I was saying, I forgot to multiply by the 10. Okay.